Welcome to the deep dive. Okay, if you need like a single snapshot of the modern space sector right now, you should buckle up because the sources we looked at this time, they really deliver this kind of fascinating chaos.
Yeah, it's quite a mix, isn't it? High-stakes politics clashing with some really fundamental engineering decisions.
Exactly. We're tracking political fights, gritty launch trade-offs, and then these, well, frankly, mind-bending astronomical discoveries that are changing the textbooks as we speak.
It really is a perfect collision. You've got these government policy battles shaping NASA's future, then the practical engineers deciding, do we ditch a booster for a bit more performance?
And then, boom, we zoom out to the outer solar system and find weird ices and rings where they shouldn't be.
It's a lot to cover.
So our mission here is pretty straightforward.
Yeah.
Guide you through these key forces. We want to distill that political fight over the moon, get into the physics of getting heavy stuff into high orbit, and then touch on these amazing scientific breakthroughs.
Sounds good. Where do we start? The politics.
Let's start right there. That really dramatic policy battle that's floored up between the private sector, specifically SpaceX, and NASA leadership.
Right. This kicked off when the acting NASA administrator, Sean Duffy, made that big announcement. He said he's reopening the competition for the Human Landing System contract.
For Artemis 3, the mission aiming to put astronauts back on the moon.
That's the one. The contract SpaceX won back in, 2021?
Yeah, exactly. And that's the mission using the modified Starship, aiming for 2028 now. So why reopen the contract? That seems like a huge, potentially disruptive move this far in.
Well, Duffy's public reasons were pretty clear. Basically, two main points.
Okay.
First, he said Starship is, quote, behind the timeline they want for Artemis 3.
Behind the 2028 target.
Right. And second, he really leaned into the strategic angle, saying the U.S. is in a race against China for the lunar South Pole.
So competition is key for him.
Seems like it.
Yeah.
He specifically mentioned wanting to let other companies back in, namely Blue Origin, to kind of diversify the approach. Hedging bets, maybe?
And Elon Musk's reaction, it wasn't exactly subtle.
No, definitely not subtle. Very swift, very public, and intensely personal.
The nicknames were certainly something.
Yeah, the Sean Dummy stuff, that got the headlines. But underneath the personal attacks, there's a strategic argument Musk is making.
About competence.
Essentially, yeah.
Yeah.
He brought up Duffy's background, the lumberjack competitor thing, world speed climbing titles.
Right, I remember seeing that.
And Musk questioned if someone with, his words, literally zero about rockets and spacecraft undermines the American space program. It's a direct challenge to Duffy's qualifications to lead NASA, basically.
So Musk's counter is all about speed versus this push for competition.
Pretty much. He argues SpaceX is moving like lightning compared to the rest of the space industry and insists Starship will eventually be able to do the whole moon mission.
And he took a shot at Blue Origin, too, didn't he?
He did. Criticized them for, quote, never having delivered a useful payload to Earth orbit. So it's speed and proven delivery versus, in his view, unnecessary competition and maybe slower progress.
And there's that deeper political layer, too, right? With Duffy also leading the Department of Transportation.
Exactly. That's a huge factor here. It brings back those old discussions about potentially folding NASA into the DOT.
Which Musk and others strongly oppose.
Fiercely. They see it as turning space exploration into just another transportation problem, not, this frontier science mission.
So Duffy mandating competition could be seen as prioritizing maybe more traditional government oversight and control over the faster, possibly riskier private approach.
That's definitely one interpretation floating around. Centralized control versus letting the private sector run, maybe faster, but perhaps with less direct oversight, a fundamental tension.
Okay, wow. That's a complex fight with huge implications.
Yeah.
Let's pivot from that high-level policy battle for a second.
Good idea. Down to the nuts and bolts.
Exactly. Let's talk about the gritty reality of launch engineering.
What?
Physics. We saw SpaceX launch that heavy Spainsat NG military satellite recently.
Ah, yes, the Expendable mission.
Right. They made that crucial decision. Sacrifice the Falcon 9 booster. Why?
It really comes down to performance needs versus reusability. That Spainsat payload was heavy, 6,100 kilograms.
And heading to GTO, Geostationary Transfer Orbit, that's demanding.
Extremely demanding on the rocket.
Maybe we should quickly explain GTO for anyone not familiar. What exactly is it?
Sure. GPO, it's a highly elliptical orbit. Think of it like a big oval path around Earth.
Okay.
The lowest point, the perigee, is usually down near low Earth orbit, maybe a few hundred kilometers up. But the highest point, the apogee, that stretches way out.
How far out?
all the way out to geostationary Earth orbit altitude. That's about 35,786 kilometers.
Wow. So why not just launch directly to that final orbit? Why this intermediate step?
It's all about efficiency.
Okay.
Rocket science efficiency using something called the Oberth effect.
Oberth effect, right. Use the fuel when you're moving fastest or slowest. Which one is it?
Well, you get the most change in energy from your fuel burn when you're moving fastest, near perigee for raising apogee. But for circularizing at apogee, you do the burn way out there where the satellite is moving slowest.
Ah, okay, so the big rocket does the heavy lifting to GTO.
Exactly. The powerful launcher, like the Falcon 9, throws the satellite onto that elliptical path. Then, once the satellite coasts up to the highest point, apogee.
It uses its own little engines.
Precisely. Its own smaller, much more fuel-efficient engines fire up to push the low point up, circularizing the orbit. This saves a ton of propellant on the satellite itself.
Which means you can carry more payload, like more antennas or fuel for station keeping, instead of fuel just for getting there.
You got it. Maximizes the useful mass.
Okay, so Spainsat was 6,100 kilograms. The booster, B-1076, it was an older one, right? 22nd flight.
That's right. It's final flight.
So why expend it? Why not recover it?
The math just didn't work for recovery. A reusable Falcon 9 landing back on Earth or a drone ship can lift about 5,500 kilograms of GTO.
Okay, so 5,500 kilogram limit for reuse.
Roughly, yeah, because it needs to save quite a bit of fuel for the boost back burn, the re-entry burn, and the final landing burn.
And Spainsat was 6,100 kilograms. So 600 kilograms over the limit.
Exactly.
Yeah.
That extra 600 kilograms meant they had to go into expendable mode. In that mode, all that fuel normally saved for landing gets used for pushing the payload.
Which gives it a much higher capacity.
Oh yeah. Expendable Falcon 9 can push up to 8,300 kilograms to GTO. So 6,100 kilograms was well within that, but impossible for reuse.
So they threw away a booster, a multi-million-dollar piece of hardware, for just 600 kilograms of extra performance. Does that still make sense economically?
In this specific case, yes, it probably did. It was a strategic choice.
How so?
Well, B-1076 was an old Block 5 booster, likely nearing the end of its planned life anyway. So it makes more sense to use that specific booster for one final maximum effort mission.
Rather than using a newer booster and expending it or just not taking the mission.
Exactly. Better to get the absolute most out of an older asset before retiring it. It highlights that even for SpaceX, where reuse is king, sometimes performance for a specific mission just has to win out.
It's a pragmatic decision. Now, you mentioned GTO insertion needs to be accurate. How accurate are we talking?
Oh, incredibly precise, especially for these valuable communication or military satellites. Getting into the right initial GTO slot is critical for the satellite to then reach its final geostationary position efficiently.
So what are the targets?
SpaceX aims for really tight margins. The perigee and apogee altitudes need to be within plus or minus 10 kilometers of the target.
10 kilometers at an apogee of nearly 36,000 kilometers. That's tiny.
It really is. And the inclination, the tilt of the orbit relative to the equator, has to be within plus or minus 0.1 degrees.
Wow. That's non-negotiable for these missions, I guess.
Absolutely. High stakes, high precision required.
Okay. So that's the hard reality of orbital mechanics close to home. Let's leave Earth orbit entirely now. Forget the politics, forget the booster landings.
Heading out to the colder, weirder parts.
Way out. Out past Jupiter, between Saturn and Uranus. We need to talk about Chiron, the Centaur object, 2060 Chiron.
Ah, Chiron. Yes, this is just fascinating stuff coming out recently.
Rings. Chiron has rings. That's huge, right? We used to think only giant planets had rings.
Well, mostly. We do have a few other small bodies, Chiriclo, Haumea, Kuar that had them. But Chiron joining the club is still a big deal.
And its rings are different, behaving strangely.
Very strangely. Observations, particularly from stellar occultations back in September 2023, showed this complex system.
What did they see?
3 distinct confined rings, pretty narrow ones, at average distances of about 273, 325, and 438 kilometers from Chiron itself.
Okay, 3 rings. What's so weird about that?
The outermost ring, the one at 438 kilometers, it's outside Chiron's Roche limit.
Outside the Roche limit. But isn't that the theoretical boundary where tidal forces should just rip rings apart? How can it exist out there?
That's the million-dollar question. It defies the standard models.
Yeah.
And not only that, the observations suggest these rings are changing over time. They're not static.
So they might be actively forming or evolving right now. We're seeing ring dynamics happen.
That's what it looks like, which is incredibly exciting. We're witnessing planetary processes in action on a small body.
And then, of course, the James Webb Space Telescope weighed in. What did JWST find on Chiron?
Ooh, JWST delivered big time. In July 2023, it gave us the first solid compositional data, and it found a surprising mix of stuff.
Like just water ice.
Amorphous water ice, yes. But also, for the first time on Chiron, detections of several volatile ices,
Yeah.
things that usually need extreme cold to stay frozen.
Volatiles, like
Carbon dioxide ice.
CO2, carbon monoxide ice. But even more surprisingly, things like ethane, C2H6, propane, C3H8, and acetylene, C2H2 ices.
Propane ice, like barbecue fuel, but frozen solid way out there.
Kind of, yeah. It's like this little world is holding onto a reservoir of frozen hydrocarbons.
That's wild. Is it just sitting there frozen? Nope. That's the other amazing part. JWST also detected gas emissions, fluorescence from methane, CH4, and carbon dioxide, CO2 gas.
So it's active. It has an atmosphere or a coma, like a
It
comet.
seems to have an active coma, yeah. Described as fan-shaped, pointing towards the sun, this little icy body, nearly 19 times farther from the sun than Earth is actively releasing gas.
How? Isn't it too cold out there for sunlight to do much?
That's what's challenging the models. The thinking now is that the activity, especially the methane release, might be triggered by some kind of low-temperature phase transition within the amorphous water ice itself.
So the ice changing its structure is releasing trapped gases, like a kind of cryogeology.
Exactly. It's not just about solar heating like a typical comet near the sun. It's potentially internal ice physics driving the activity. It's completely reshaping how we think about these Centaur objects.
Wow, a tiny world rewriting the rules, 18 light hours away. Incredible. Okay, but we have to swing back to Earth, back to conflict.
Right, there was another heritage-related fight brewing, wasn't there?
Yes, a really bitter political and cultural fight over a piece of history, the space shuttle Discovery.
The relocation mandate. Discovery is currently at the Smithsonian's Udvar-Hazy Center out in Virginia, right?
That's right, the big annex near Dulles Airport. But there's this law, the Bring the Shuttle Home Act, which got folded into a bigger bill that was signed.
And it mandates moving Discovery.
Yes, mandates moving it to Houston specifically within 18 months. So Congress says it has to move. Why is the Smithsonian pushing back so hard? It seems like a straightforward directive.
They're arguing it would essentially destroy the artifact. They say Discovery was preserved meticulously after its last flight, specifically for research access, and it was never designed to be taken apart again.
Taken apart how?
Significantly. The Smithsonian warns that moving it would require cutting it into at least 6 major pieces: wings, payload bay, maybe the tail section.
Cutting into the actual structure.
Yes. They claim this would cause irreparable damage, severing miles of internal wiring, potentially damaging the structure, and maybe even requiring the removal and likely destruction or replacement of thousands of those unique thermal protection tiles. They say its historical integrity would be lost.
Oof. That sounds bad. And there's a money issue too, right?
A big one. Congress allocated $85 million for the move.
Which sounds like a lot.
It does, but the Smithsonian's estimate for actually doing this disassembly, transport, and reassembly safely is way higher. They're saying somewhere between $120 and $150 million.
So a massive budget shortfall on top of the damage concerns. What's the legal argument? Who actually owns the shuttle?
It's tricky. The Smithsonian claims they received all rights, title, interest, and ownership back in 2012, and they hold it as a public trust. Their argument is they own it, and Congress can't just order them to destroy it.
But the other side, the proponents of the move.
They argue that the Smithsonian itself is a creation of Congress funded by taxpayers, and therefore it must comply with a federal law, a mandate from Congress.
So it's ownership versus congressional authority. Where does it stand now?
Kind of in limbo, tangled up in broader government funding negotiations and potential shutdowns. Its fate is very much up in the air.
So today we've really seen the whole spectrum, haven't we? Billion-dollar fights over future moon landings, arguments over how to preserve our space history.
And then contrasted with the hard, practical engineering of just getting a satellite launched correctly.
Right. From political drama and heritage battles to the quiet, profound science happening late hours away with Chiron.
It really does show those two narratives playing out constantly in space. The loud, immediate, very human conflicts over money, control, and legacy.
Versus the slow, patient, often surprising march of scientific discovery that just keeps finding things that challenge what we thought we knew.
And speaking of challenging what we knew, there were those couple of other quick but really significant discoveries recently too, weren't there? On the astrophysics side?
Oh, right. Good point. To underline that breaking theories theme. First, Betelgeuse, the red supergent star.
Yeah, the conformation of its companion star, nicknamed Beetle Buddy, apparently.
Beetle Buddy, okay. And the issue there is the mass difference, right?
Exactly. Betelgeuse is huge, maybe 16 or 17 times the mass of our sun. Beetle Buddy is tiny in comparison, only about one solar mass.
So a giant and a dwarf orbiting each other.
Pretty much. And that extreme mass ratio is really hard to explain with current models of how binary star systems form. How do you get such different stars forming so close together? It challenges the theories.
Okay, interesting. And the other one was an exoplanet.
Yes, a big find for exoplanet hunters. A super-Earth called GJ251c,
Super Earth, meaning bigger than Earth.
about 4 times the mass of Earth. And the exciting part is its location.
Habitable zone.
Smack in the habitable zone of its star, a red dwarf. And the really exciting part, it's close.
How close?
Only 18.2 light years away. Astronomically speaking, that's practically next door.
Wow. 4 times Earth mass, habitable zone, 18 light years away. That makes it a prime target for, what, the Webb telescope again? To look for an atmosphere?
Absolutely. Its proximity and location make it one of the best candidates we have right now for future atmospheric studies, searching for potential biosignatures. It's a reminder that while we're arguing over shuttles here, there are potentially world-changing discoveries waiting just a few light years away.
So wrapping this all up, what does this chaotic snapshot mean for you, the listener? As you think about, say, the precision needed to launch Spainsat versus finding propane ice on Chiron.
Consider those two powerful, often opposing forces driving things in space today.
On one side, you have the very immediate, very human, political and economic conflicts. Billions of dollars, national prestige, historical artifacts, things that dominate the headlines.
Yet on the other side, you have the slow, steady, impartial process of scientific discovery, the observations from telescopes like Webb, the data from probes, constantly revealing a universe far stranger and more complex than we imagined, overturning old ideas about rings or stars or where life might exist.
So the final question for you to ponder. Which of these forces, the loud, immediate human conflicts or the quiet, persistent march of discovery, which one do you think will ultimately have the greater, more lasting impact on humanity's future path out there among the stars?